Hello everyone, the power of pi here, and today we're going to be looking at a problem from the 1999 AHSME. It's a nice number theory problem. So we have unique integers a2 all the way to a7 such that this following equality holds, where we have a certain condition, specifically that ai must be greater than or equal to 0 but strictly less than I, for I equals 2 all the way to 7. And you want to find the sum of these 6 numbers. So the first thing I'd do is get rid of fractions by multiplying by 7 factorial. Doing so, I get 5 times 6 factorial is equal to 7 times all the way until times 3 a2 plus 7 all the way until times 4 a3 plus all the way until 7 a6 plus a7. So now I see that every single term here has a 7 in it, except a7. So I'm tempted to take mod 7 on both sides. So on the left-hand side, if I take mod 7, 6 factorial is -1 mod 7 by Wilson's theorem. So the left-hand side is -5 mod 7 or 2 mod 7. So 2 would be congruent to anything with the 7 disappears. So we get a7, or I can kind of write that better as a7 is congruent to 2 mod 7. And we know by this kind of restriction that a7 must be 2 in that case. So now I'll do 5 times 6 factorial. That's 5 times 720, which is 3600. So I'll bring that 2 over and divide by 7 now. So I get 3598 divided by 7 is equal to 6 times all the way to times 3 a2 plus 6 times 5 times 4 a3 plus all the way until 6a5 plus a6. And then 3598 divided by 7 is like 514. So again, I have a bunch of 6's now, so I'll take mod 6 on both sides. Therefore, I get a6 is congruent to 514 divided by 6 is 85 with the remainder of 4, so that's 4 mod 6. And then by that restriction, we know that a6 is equal to 4. So now you see the pattern. We plug in a6 equals 4, and we rinse and repeat. So we'll have 5 times 4 times 3 a2 plus 5 times 4 a3 plus 5 a4 is equal, and then plus a5 is equal to 510 over 6. And 510 over 6 is 85. So now what I need to do is I have a phi in almost everything. I'll take mod phi. A phi is therefore congruent to 0 mod phi. By the restriction, we know that a phi is therefore phi, since it must be strictly it must be less than or equal to 0. So then therefore a phi must be 0. And then now dividing out by phi, we get 4 times 3 a2 plus 4 a3 plus a4 is equal to 17. And then mod 4 gives us a4 is 1 mod 4. By the restriction, we know a4 is 1. A7. Did I box a6 somewhere? Yeah, a6 is here. Okay, so we know that a4 is 1. Therefore, we know that 3a2 plus a3 is equal to 4. And then from there, we can take mod 3, or we can just easily see that a3 has to be 1 and a2 has to be 1. So now we want the sum of this. That gives us 1 plus 1 plus 1 plus 4, that's 7, plus 2, that's 9. So our answer is B, and we are done. So make sure to subscribe, like, and I'll see you guys in the next video.